Hi. Let's continue our session with the topic homologous series. Homologous series, and we'll explain with some examples also. First of all, let us understand what is homologous series. A homologous series is a group of organic compounds having similar structures and similar chemical properties in which the successive compounds differ by CH2 group. Those organic compounds shows homologous, they are called as homologous compounds. Homologous compounds. Let's understand with examples. So, the homologous series is a group of organic compounds having similar structures and similar chemical properties in which successive compounds differ by CH2 group. Differ by CH2 group, having same kind of compounds, same kind of structures, same chemical properties, but each compound differ with a CH2 group. CH2 group, right? So, all the alkanes. Before that, let us understand the characteristics of homologous series. First, all members of homologous series can be represented by the same general formula. For example, alkanes. Alkanes general formula CnH2n plus 2 as we know. Similarly, for alkenes, unsaturated hydrocarbon, general formula is CnH2n. Then the third one is alkynes. Third one is alkynes. Third one is alkynes. Alkane general formula CnH2n plus 1. Then for alkynes formula CnH2n minus 2. As yesterday we discussed all these things, right? General formula of saturated hydrocarbons called as saturated hydrocarbons, alkanes, unsaturated alkanes, alkenes and alkynes. So all members of homologous series can be represented by the same general formula. For alkanes, CnH2n plus 2. For alkenes, CnH2n. For alkyne, CnH2n minus 2. Right. Second characteristic. So let us discuss example along with characteristics also. Any two adjacent homologies differ by one carbon atom and two hydrogen atoms in their molecular formula. For example, methane. So methane and one carbon. So we can write CH4. Then ethane. Eth means 2. C2H6. Then propane. C3H10. Butane. C4H10. So these are all of the alkanes: methane, ethane, propane, butane. So methane CH4. Then ethane. Ethane, though when I compare with methane, ethane has one carbon extra. Here one, one carbon, 4 hydrogens, 6 hydrogens. How many different CH2? So the two adjacent organic compounds differ with one carbon atom, 2 hydrogen atoms. When compare these two, similarly, two carbon atoms, two carbon atoms in ethane, 3 carbon atoms in propane. So difference 1 carbon. 6 hydrogens in ethane, 8 hydrogens in propane. Difference 2 hydrogens between ethane and propane. Similarly, propane 3 hydrogens, 3 carbon atoms, butane 4 carbon atoms, 1 carbon atom different. Propane has 8 hydrogens, butane has 10 hydrogens. So again 2 hydrogens are different. So any two adjacent homologous gases differ by 1 carbon atom and 2 hydrogen atom in their molecular formula. Ethane CH4, ethane C2H6, difference CH2, one CH2 group. Ethane and propane, one CH2 group. Butane and propane and butane CH2, like pentane, hexane, heptane, octane. In case of alkenes, so let us understand. In case of alkenes general formula CnH2a. If one carbon atom and then one C1H2, so CH2 the group we can generally in organic chemistry it is called as a methylene group. If carbon is 2 carbons you have 2 to 4 C2H4, it is ethene or ethylene. So methylene group has 1 carbon atom, 2 hydrogen atoms. Right. When compared with ethane has C2H4, means 2 carbon atoms, 1 carbon atom, 2 hydrogen atoms. Difference 1 carbon, 2 hydrogens. 1 carbon and 2 hydrogens. Ethene. For example, if it is 3, n is equal to 3, C3, 3, 2, 3 are 6. C3H6, it is propene. So, okay, right? When you write, see, propene has 1 carbon extra, 1 carbon, 2 hydrogens in propane. So CH2 is difference. Right? So in this way, there is a 1 carbon atom and 2 hydrogen atoms are different in their molecular formula. Methylene molecular formula CH2, ethylene molecular formula C2H4. C2H4 has 1 carbon atom, 2 hydrogen atoms, more than methylene. Similarly, propene formula C3H6. So has 1 carbon atom, 2 hydrogen atoms, more when compared with ethene. So when if you write a structure, for example, C double bond C H2, this is ethene. Propene CH3 C double bond CH2, where hydrogen CH, carbon double bond 1, 2, 3, 4 satisfied. 1, 2, 3, 4 satisfied. This is eth, this is propane. 2 hydrogens. Here 1, 2, 3. 3 hydrogens. 3 carbons. 2 carbons going to 1, 2, 3. 3 carbons. 1 carbon extra. 2 to 4 carbons. 3, 4, 5, 6. 2 carbons extra. Similarly, for alkynes. These are the homologous series of alkanes, alkenes and alkynes. I am explaining 3 at a time by understanding the characteristics. If n is equal to 1, C 2 minus 2 or 2 minus 0. So, you did not observe triple bond in between carbon and carbon. If C is equal to 2, C into H 2 into 2, 2. So C2 H2 is 4 minus 4. It is called as acetylene generally, but it is called as ethane. It is called as ethane. Structure C triple bond C H H. Then if C is equal to, if N is equal to 3, so C3, 2 3 are 6 minus 2, 4. C3H4. This is propane. This is called as propane. C2H2, ethane or acetylene, propane CH3. 1 carbon extra, 2 hydrogens also extra. So difference between these two and these is 1 CH2 group. 1 CH2 group. So try to understand the simple one only. Just count the number of carbon and hydrogen atoms between the same organic compound, same type of hydrocarbons. So here 1 carbon, here 2 carbons, 3 carbons, 4 carbons. For every compound has 1 extra carbon, one carbon more. Then hydrogen 4, 6, 8, 2 hydrogens. 1 carbon, 2 hydrogen. Here also 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. 1 carbon, 2 hydrogens. If N is equal to 4, C4 H 8 minus 2, 6. This is called as butane. This is called as butane. 2, 3, 1 difference. 2, 4, 2 difference. 3, 4, 1 carbon difference. 4, 6, 2 hydrogens difference. So, any two adjacent homologous differ by 1 carbon atom and 2 hydrogen atoms in their molecular formula. Then the difference in the molecular mass, the total mass of any two adjacent homologous is 14 units. 14 units. Why? So carbon atomic number is atomic weight 12 units or atomic mass. Carbon atomic mass 12 units. Hydrogen atomic number 1 unit is the atomic mass. So what is the adjacent homologous are differ by 1 CH2 group. Differ by 1 CH2 group. Let's calculate the molecular mass of this CH2. So carbon atom told 12. Hydrogen 2 plus 1, so 12 plus 2, that is equal to 14 units. So the molecular mass of this CH2 group is 14 units. This 14 units. So similarly, 1 carbon, 4 hydrogens and 12 plus 4, 16 units. Molecular mass of methane is 16 units. 16 units. Then molecular mass of ethane, 2 carbons, 2 plus 6, 30. 30. Then here 3 plus 12 plus 8 into 1. 12 to the 36 plus 8. So 40. So 30 minus 16. 30 minus 16, 14 units. Then 44 minus 30, 14 units. So the difference in the molecular mass of any two adjacent homologous is 14 units. So 14 units. Molecular mass of methane 16 units. Ethane 30 units. Difference between 30 and 16, 14 units. Molecular mass of methane 30 units. Propane 44 units. Difference 14 units. Similarly, CH2 already just we calculated 14 units. Then C2H4. C2H4. 2 plus 2 into 12 plus 4 into 1. 24 plus 4 is equal to 28. Again difference 14. Here 3 into 12 plus 6 into 1. 32 plus 6. Towards the 36. 36 plus 6, 42. Again difference 14. So difference means difference in the atomic mass. Difference in the atomic mass of two adjacent homologous organic compounds or homologous compounds is 14 units. Similarly, C2H2 2 plus 2 plus 2 into 1. So 24 plus 26 units. 26 units is the atomic mass or molecular mass of ethane or acetylene. Acetylene molecular mass 26 units. Then propene 3 into 12 plus 4 into 1. 36 plus 4, 40. Here 26. 40 minus 26, 14 units. 14 units. So the difference in the atomic mass of two adjacent homologous of compounds is 14 units. Is 14 units. Molecular mass means the total mass of the molecule. How do we calculate total mass of molecule? By sum of all the mass of individual atoms of the elements, which are learned in class 9. Right. Then shows similar chemical properties. Shows same chemical properties. All compounds of homologous list show similar chemical properties. All the compounds of alkanes, methane, ethane, propane, butane has same chemical properties. Similarly, alkenes like ethene, propene, butene, pentene, all having same chemical properties. Alkynes like ethane, propane, butane, all having same chemical properties. Then, so all the compounds of homologous series shows same chemical properties, but differ with physical properties because of there is some variation in the number of carbon atoms. There is a variation in the number of carbon atoms, so they shows different physical property. For example, if in the alkane series, as the number of carbon atoms for molecules increases, the melting points, boiling points, densities of all the members, all the alkane atoms, all the alkane molecules differ because of there is a variation in the carbon number. There is a variation in the carbon variation in the carbon number, all the alkane compounds like methane, ethane, propane, butane shows different melting points, boiling points, densities, etc. Right? So in this way, so similarly we have so many organic compounds. Every group of organic compound shows